Welcome to an in-depth look at an innovative solution for public safety. Our topic today is automated fire detection from video streams using deep learning. Fire accidents cause severe loss of life and property, and early detection is critical to prevent disasters. This system is an AI-powered surveillance solution that automatically detects fire in video feeds using deep learning, enabling faster alerts and improved safety response. Traditional fire detection methods, such as smoke sensors or manual monitoring, are limited in coverage and may fail in outdoor or large-scale environments. They often detect fire only after significant damage has occurred. Video-based fire detection offers a smarter alternative, continuously monitoring environments using existing cameras. Data acquisition involves collecting fire and non-fire images from public datasets like Kaggle. These images are cleaned to remove duplicates and corrupted files, then each frame is resized to 224 by 224 pixels. Pixel values are normalized between 0 and 1, and the dataset is split into training, validation, and testing sets to ensure reliable model performance. At the core of our system is VGG16, a powerful pre-trained convolutional neural network. VGG16 contains 16 deep convolutional layers, enabling strong feature extraction. Transfer learning allows reuse of ImageNet-trained visual features, with lower layers frozen while higher layers are fine-tuned for fire versus non-fire classification. VGG16 outperforms other models due to better feature depth, faster convergence, and strong global and local feature representation in a single pipeline. Real-time video frame processing begins with video streams being processed using OpenCV. Each video frame is extracted and pre-processed, then passed to the trained VGG16 model. The model predicts the probability of fire in each frame. When fire is detected, the affected frame is highlighted, and the system displays fire detected alerts. Precaution instructions are shown to guide immediate action. The web interface, built using Flask, allows users to upload a video file. The system then analyzes the video in real time, and detection results are displayed alongside the video output. Fire or non-fire status is clearly indicated, and the interface is lightweight, browser-based, and accessible from any device. Our system leverages a robust tech stack including Python, Flask, VGG16 for transfer learning, OpenCV, NumPy, SQLite, and HTML templates. This system demonstrates how deep learning combined with video analytics can significantly improve fire detection accuracy and response time. Future enhancements include live CCTV camera integration, SMS or alarm-based alert systems, smoke and flame multi-class detection, and cloud-based real-time deployment. Thank you for watching. This is AI-based fire detection, enhancing safety through intelligent vision.